Let's move on to the third method of side solving now. The first one was MARPAS, second was longitude by chronometer, and the third one which we have is the intercept method. The intercept method is interchangeable with the long by chron. In any situation where longitude by chronometer method can be used, the intercept method also can be used in place of long by chron. So at any time before the meridian passage of the body or after the meridian passage of the body, we can use this intercept method and find out the position line. Now let's see the procedure to solve a intercept question. We will see the information provided and how do we proceed ahead, what is the formula, and how do we obtain the PL and its direction. Now the information provided in these questions is exactly similar to what was provided in longitude by chronometer. So the information is they will give you the date and time. The time could be GMT, which is given in most of the question nowadays, or could be chronometer. In case of chronometer, there could be a chronometer ambiguity, which is resolved using the AM/PM indication given in the question. The second set of information is the sextant altitude, and along with it, they provide us with the index error of the instrument of the sextant and the height of eye of the observer, which is required for dip correction. And the third set of information was the DR position, the DR latitude, as well as the DR longitude. So if you see, the information provided to us is exactly similar to what was in longitude by chronometer. So let's see the method also. The method is also quite similar. First of all, we enter into the almanac to get the information regarding the celestial body. We find out the hourly GHA from the daily page, the date page. Hourly GHA is obtained. We get the increment from the increment table, increment for the given minutes and seconds of the time. Then we pick up the V correction. V correction is required for planets and moon. So the hourly value of V correction is picked up from the daily page and its increment is taken from the increment table. Once all these three are combined, we obtain the accurate GHA of the body for that particular instant of time. Now, once the GHA is obtained, we also have the DR longitude known to us. We apply the DR longitude and we get the LHA of the body. From the LHA, we can easily obtain angle P of the body. P will be equal to LHA if LHA is less than 180, and P will be equal to 360 minus LHA if it is greater than 180. The second item which is given in the almanac is the declination of the body. So we get the hourly declination from the daily page. We apply the D correction. D correction is given, hourly figure is given on the daily page. We get the increment from the increment table. And after applying it, we get the correct declination of the body. So this is the first step in which we get the GHA of the body, the LHA, angle P, as well as the declination of the body. Now in the second step, we have the sextant altitude. We apply the index error. If it is on, we put it off. If it is off, we put it on. Then we apply the height of eye with the dip correction. So dip correction is always negative. And once we apply these two corrections, we get the apparent altitude of the body. And to this apparent altitude, we apply the total correction and we get the true altitude of the body. Up to here, the method is exactly same as long by chron. Now comes the difference. From this true altitude, we obtain the true zenith distance of the body. We know the true zenith distance is equal to 90 minus true altitude. So we get the true zenith distance of the body. Once these items are obtained, we are now ready to go into the intercept formula. So let's see the intercept formula now. The intercept formula says cos of CZD, that is calculated zenith distance, is equal to cos of P multiplied by cos of latitude multiplied by cos of declination plus minus sine of latitude into sine of declination. Let me explain to you these terms one by one. The first term here is calculated zenith distance. Till now we have seen three types or three different zenith distances. One was the true zenith distance. Second was the MZD, meridional zenith distance. And this is the third one now, CZD, that is the calculated zenith distance. Now, what is the difference between all these three? The true zenith distance is what is obtained from the true altitude, which is obtained from a site, from an observation. So if you get the true altitude and you use it to get the true zenith distance from a observation, from a site or observation which you have taken yourself, that is known as true zenith distance. Why it is called as true zenith distance? Because there is no scope of any error or inaccuracy in that zenith distance. The second one is MZD, meridional zenith distance. If we get this true zenith distance at the time of meridian passage, marpass, just to differentiate it from a normal zenith distance, it is named as MZD. So MZD is nothing but the true zenith distance at the time of marpass or at the time of meridian passage of the body. Now coming on to the calculated zenith distance. Now TZD and MZD were both obtained with observations. We used the sextant, and from the sextant we obtained the true altitude of the body, and that was used to get the TZD or MZD. Now there is a way with which the zenith distance of the body can be found out without an observation. That is by using the formula. Now this intercept formula which you see is basically the formula to calculate the zenith distance of any particular body. Just to give you an example, if I tell you to calculate the zenith distance of the sun for tomorrow, if I want you to calculate the zenith distance of the sun for tomorrow, what will be the zenith distance at this particular time tomorrow? So you obviously cannot find it out with observation. It has not yet happened. With observation, you can only find it in real time. But if you want to calculate it for the future, it can be done using this particular formula, the intercept formula. So when we use the formula to calculate the zenith distance of a body, it is known as CZD. The C standing for calculated tells us that this zenith distance has been obtained using the formula and it is not from a site or observation. So cos of CZD, that is the calculated zenith distance, is equal to cos of P. P is the angle P of the PZX triangle into cos of latitude. The latitude used here is the DR latitude, that is what we have, into cos of declination. The declination of the body has been obtained from the almanac, plus minus. Again, you see two signs here in the formula. The same fundamental is used, what we used in long bicron. That is, upper sign is used when the following terms are of the same names. There are two following terms. One is latitude, another is declination. So if lat and dec are of the same name, we will be using the upper sign, which in this case is plus. And the lower sign is used when latitude and declination are of the opposite names or different names. So be careful, in the long bicron formula, the minus sign was on top, and in the intercept formula, the plus sign is on top. So latitude again is known to us. The DR position is available in the question. The declination has been obtained from the almanac. So you see the right hand side, all the terms are available to us. P is known, we calculated P from LHA. Latitude is known, declination is known, lat and dec. So once you put all these values in the calculator with a single step calculation, you will be able to find out what is the calculated zenith distance of the body. So this is the intercept formula, a very important one. It should be memorized, and you should make sure that you do not make any mistakes in the formula. Now once CZD is found, what we do is we get the difference between TZD, that is the true zenith distance, and CZD, the calculated zenith distance. We find out what is the difference between these two, and this difference is what we call as the intercept. So intercept is nothing but the difference between the true zenith distance and the calculated zenith distance. Now once the intercept is obtained, we have to name the intercept. It is named in two ways. Either it can be towards the body or it can be away from the body. So towards the body or away from the body. Now, what decides whether it will be towards or away? Now for that, we use a shortcut method, a naming method, which is known as TTT. TTT, this is just a simple way or technique to memorize how the intercept is named. In the later slides, I will tell you what is the concept behind it. But as far as the solving of the practical question is concerned, you should be using this TTT, which is very quick and easy. And it tells us what will be the name of the intercept. What does the TTT means? First T stands for true. That means the true zenith distance. Second T stands for tiny. Tiny means smaller. And the third T stands for towards. So true, tiny, towards. That means if the true zenith distance is tiny, tiny means smaller than the calculated zenith distance, the intercept will be towards, and vice versa. So if the true zenith distance is tiny, intercept will be towards. If the true zenith distance is not tiny, the intercept will be away. So this is how we name the intercept. Naming is required to plot the position line. Later on, when I show you the diagram, it will become clear to you how is the naming used in plotting the PL. So once we obtain the intercept, the next step in the calculation is to obtain the direction of the position line. And as we know that in celestial navigation, the direction of the PL is always perpendicular to the azimuth of the body. So we find the azimuth of the body now in the next step. Azimuth is found using the same ABC method. A is equal to tangent latitude upon tangent P, named opposite to latitude if P is less than 90, and named same as latitude if P is greater than 90. Then B is equal to tangent declination upon sine of P, named same as declination, and once these are obtained, combining them together, a plus minus b or b plus minus a, will give you the value of c, which is used in this formula. Tan azimuth is equal to 1 by c into cos latitude, giving you the azimuth of the body. Once the azimuth is obtained, the position line is perpendicular to the azimuth of the body. So these are the two items which we require. One is the direction of the PL. This is what we require. And second is the intercept. So once we have these two known to us, we are able to plot this position line on the chart or on our answer sheet in a plotting question. And the question is solved. Let's now see, once the direction and the intercept is obtained, how do we plot the PL? We use the DR position as our reference. So we have the DR latitude, which is plotted in the diagram now. We have the DR longitude, which is plotted as a vertical line. So this is our reference position, the DR position. Now at this position, we mark the azimuth of the body. Let's assume the body is somewhere here. The azimuth will be the direction in which the body is. So the red color line represents the azimuth of the body. Now we have the intercept. Let's assume we have intercept equal to 3 miles towards. So what that basically means is, from the DR position, we go towards the body. And how much distance we go? We move a distance equal to the intercept, that is 3 miles. So from the DR position, you go towards the body a distance which is equal to the intercept. So once you cover that much distance going towards the body, the point where you reach is the point from where the PL will be passing. This point is known as intercept terminal point, or ITP. Now this is the point from where the PL position line will be passing, and the direction of the PL, as always, will be perpendicular to the azimuth of the body. So this is the ITP, the intercept terminal point. And we have the PL also plotted on the diagram now. The green line with the double arrows marked on both the ends is our position line. Now, whenever we plot a position line on the chart or on our diagram, on our plot, we always indicate it by making arrows on both the sides, representing that this line is not contained to what has been drawn. This can be extended to both the sides. It can be extended to both the sides, and the vessel's position may lie anywhere on this line segment extended. So this is the intercept plot.